up, guys? Since I'm building an RC plane, let's talk more aerodynamics. Today, we got drag. In aviation, there are two types of drag, parasite and induced drag. Let's talk about induced drag first. On an airfoil, let's say the wings, for example, high pressure on the bottom of the wing chases the low pressure on the top of the wing. This high pressure chasing the low pressure creates this thing called wingtip vortices. And what these wingtip vortices do is that they tilt the lift vector back, which causes the induced drag. As you can see, you have these wingtip vortices here, and you can see the lift vectors being tilted back a tiny bit, and that creates induced drag. We call induced drag a byproduct of lift, but there is a different type of drag, and that's parasite drag. Basically, parasite drag is drag that isn't a byproduct of lift. There's three types of parasite drag: form, skin friction, and interference. Let me explain those to you simply. Form drag is basically the shape of the airplane and it hitting the relative wind, creating drag. Skin friction is similar to form drag with things like chipped paint or like cracked lights or rivets on the airframe causing drag and making the airflow less smooth. Interference drag is kind of hard to explain and it's kind of hard to understand really, but it's basically two different parts of the airplane causing different directions of airflow, and when those collide, drag happens. For example, the wing and the fuselage, and also on the landing gear on this low-wing aircraft. One more thing though. Lift-induced drag decreases as velocity increases, but parasite increases as velocity increases. I'm not going to explain why right now because it's kind of a long explanation, but I want to show you something cool. As you can see, you got the parasite drag going up as velocity increases and the lift-induced drag going down as velocity increases. And if you add them up, it makes this total arc. At the bottom of the arc, what do you think that is? That bottom of the arc is the best speed where there's the least amount of drag. Most aircraft use this speed for their glide speed and their best rate of climb speed. For example, the Piper Archer 3 that I fly at flight school, the best glide speed is 76 knots. I'm still working on the RC plane right now, but follow for more and stay tuned. See y'all.